Hello, my name is Michael Llanes,
And I'm Sharon McAtee.
and this is our project about extracting some SMU packet information using T-Shark and other tools.
So, our main motivation was to have a project that could transition well into any future cybersecurity projects that we encounter. Packet analysis is commonly used to detect unusual behavior or to monitor activity, and we could also take a look at things like bandwidth usage. Overall, we saw a dominance of HTTPS traffic across all scenarios, and we also found that most communication is done over port 443, showing how modern applications rely heavily on those encrypted connections.
So we used a variety of tools throughout this project. The biggest one was, of course, T-Shark, which is the command line implementation of Wireshark. So we were able to use that in a couple of seconds. We'll go over that in our methodology, but it helped us to capture packets. And it helped also when we started implementing Python. We were able to use T-Shark Py, I think is the name of the library. They essentially have a lot better interface and usage within Python than if we were actually using Wireshark. Speaking of Python though, a lot of our project was done in Python, so we were able to utilize some pandas libraries and also a library called ipLocate, which Sheridan will talk about now.
Yeah, so ipLocate is actually a geolocation API which we use to then download GeoLite 2 because the company that owns it has to make it as difficult as possible to reach GeoLite 2. But that's just a database that we can map IP addresses onto physical locations with, and this is used by a lot of cybersecurity companies to detect fraud.
So going into a little bit of our methodology, the first thing is the traffic capture, which we ended up doing with T-Shark. So I'll go ahead and run a small simulation here for us now. So we have a command here, which is going to be, actually, let me do this because it's in here. Boom. So this is calling the T-Shark path, and then our port is 5, which is going to be our Wi-Fi port. Our duration is going to be 30 seconds, and we're going to output in this capture.cpap file. So if we go ahead and run this, it's going to start capturing on Wi-Fi. And now if I open a Google Chrome browser and I just go around and let's say I visit, Canvas, it's going to be capturing all this data as I'm trying to navigate there. And the Wi-Fi is slow, but that's okay. Well, what else is new?
Well, at least it's not hacked today.
At least it's not hacked today. Honestly, this may take the whole 30 seconds. And it did. Wonderful. So, as you can see, we went ahead, and if we look into our directory, we do now have our capture.pcap. So we can then go back to our methodology, which is in our Python scripting. So as you saw, we do have a Python file here, which is called analyzetraffic.py. So if we go ahead and run this, traffic.py, and we're going to be analyzing our capture.pcap. So it's going to run for a little bit. It's going to kind of look at everything that we're doing here. It's going to read in the files some summary statistics here. We had, it said 28 seconds, so you can see that there's some disparity there. But it's just a little bit for this example here. We had some anomalies that were detected, which is good because it means that there's things to actually analyze and write about. And of course, we generated some output charts. So that is the last part here, plot analysis. As part of this Python file, I did a lot of work with matplotlib. So if we go into our output, we can look at everything that was made. So the first thing that I like to look at is the bandwidth over time. So you can kind of see how it started to look at how the internet was used. There's this giant spike here when we tried to load in our web page. And some smaller spikes when Google was loading up, and it was probably starting some of my extensions that I had. And then, of course, we could go ahead and look at some of our other things that we have. For example, one of the things I'd like to look at is our protocol breakdown. So we've got mostly TCP packets being sent with some QUIC, some TLS, some DNS, and some very small other packets. And mostly that DNS and background packets is going to be our background. But, this is just a little summary of how these things get made. And then the last thing that I wanted to show was the IP summary.csv. This shows where all the IPs that were taken from in that file, how many packets got sent for each one, how many bytes, and is again just useful information for our analysis later on. So that's kind of our methodology. We applied that to 3 different scenarios, and we did 10-minute segments instead of these 30-second segments. And we can go ahead and talk about some of those now. So first of all is our idle scenario. So our idle scenario, I closed down absolutely everything on my computer. I had absolutely nothing done. I just did 10 minutes of literally no interaction with my computer. But as you can see, there is still some data. There is still some stuff being sent back and forth.
Yeah, and we're also seeing that the computer is still generating some regular network traffic, even without any user activity. So that's pretty interesting.
Yeah. So this also just helps us to determine a baseline for what we're looking at in our other scenarios. So our second scenario here ended up being web browsing. So again, we started capturing data, and then kind of like we did just before, we just visited a bunch of different websites, did a couple of different things, let their websites run and do whatever they wanted to.
So we're seeing a lot more diverse traffic patterns. The computer is communicating with many different servers, including Google, of course. Yeah.
And then when we were doing the web browsing section, I specifically visited an HTTP website in order to not get that encrypted HTTPS data and kind of see how we could work with that. And indeed, when we ran the code, some anomalies were flagged because of that. And then our final scenario that we wanted to look at was we just put on a 10-minute YouTube video. So you can see that most of our data is, most of our packets are data types. And what specifically I find interesting is this bandwidth over time, because it's buffering in a portion of the video, and then it's kind of thinking about, let the video run. Oh, we need more video, so it goes and it downloads that video, and then it lets it run. So interestingly enough, this is the most consistent of all of the bandwidths. Because most of these have large spikes whenever they go to load up the website, but then very small spikes carrying on, whereas YouTube consistently takes in the most.
That's good. Nice. Okay. So just bringing it back to that Geolite 2 database I talked about earlier, we use it to analyze source and destination IP addresses. We also get like a continent breakdown from the code we created, but it's not super interesting because it's mainly in North America. I figure you don't want to look at that. So for the idle scenario, obviously we're seeing mainly US as a destination address, but we're also seeing unknown. And this could be for a number of reasons, but we're thinking it's likely just due to background processes that are still happening even with supposedly nothing put up on screen, nothing going on. And then for the YouTube capture, we're seeing the source country mainly being the United States, which makes sense, but we're also seeing a few in the Netherlands and Luxembourg and a few others less notable countries, which may just mean that there's some edge cache or some backend service that's hosted in one of these countries.
Yep. That was pretty much everything that we had to show. We ended up finding out a lot of useful information, especially about how to kind of analyze these different sources. Sorry. But again, I'm Michael. I was working a lot with the Python script and the T-Shark implementation, and then of course writing some of the report.
And I'm Sharon, and I did what it said on screen, except for this slide, which is why there's 2 T's in my last name.
Ooh, that's on me.
It's okay.
Damn,
it's okay.
I mess that up every time.
But otherwise, I love doing presentations, so I did that bit.
Excellent. So thank you so much for your time, and we'll hear from you soon.